We're going to look at proportionality theorems in lesson 60. And let's look at theorem 60-1. Let's kick this thing off. And what 60-1 says is the triangle proportionality theorem. It says if a line is parallel to one side of a triangle, okay, parallel to one side of a triangle, intersects the other two sides, it divides those sides proportionally. So here we have a line that intersects two sides in xy and xz, and is also parallel to the base. Well, since we have that, then we know that the triangle is proportional. Here's what's proportional. XA over AY is proportional to XB over BZ. So it's kind of the top side here over the bottom side is proportional to the top side here over the bottom side. So let's look at a couple of examples. Example 1, A says to find AE. I'll show you where AE is. That's AE. And so we're going to use the triangle proportionality theorem. We're going to do because we see these little parallel signs, and it goes through, it intersects opposite sides here. We're going to do top over bottom. So I'm going to do 2 over 3 is equal to AE over 5. Then you can solve. 5 times 2 is 10 equals 3AE. So when you divide by 3, you get 10 over 3 for AE. You get a fraction. It's okay. That's the right answer. Then in example B, what does it want us to find? It wants us to find x. Find the value of x. So we can do the same thing. We can set up a proportion because we know that these lines are parallel and it goes through the sides of the triangle. So we do top over bottom, x plus 1 over 5 equals top over bottom, x plus 3 over 10. Cross multiply. Now when we cross multiply, it looks like this. We're doing 5 times the quantity of x plus 3 equals 10 times the quantity of x plus 1. So we have to distribute. Lower this a little bit. We distribute 5x equals 15 plus 15, getting ahead of myself, equals 10x plus 10. Combine like terms, subtract 5x, subtract 10, and we get 5 equals 5x, therefore x equals 1. And so we found x, but that is all from the triangle proportionality theorem. Now let's look at example 2. What example 2 is, it's about the converse of the proportionality theorem. The converse states that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So converse, working backwards in a sense, is we're going to say, okay, if 3 over 8 is proportional to 2 over 7, that is going to prove that these lines are parallel. But we do not know yet. We have to test the ratio. So I do 3 over 8, short over long in a sense, equals 2 over 7. Now let's see if they're equal. 7 times 3, 21. 8 times 2, 16. Those are not equal. Therefore, they are not parallel lines. And that's all the converse of, that's all the converse of the triangle proportionality theorem is. Now let's look at example 60-3. Theorem 60-3. What that says is if parallel lines intersect transversals, then they divide the transversals proportionally. So if parallel lines, here's 3 parallel lines, if they intersect these transversals, here's our transversals, then they divide them proportionally, as long as they're parallel. So we can set up proportions. We need to find A, B in this example, right here. And so we can set up proportions. Now you could actually do your proportions different ways. You could do x plus 3 over 4. Oh gosh. X plus 3 over 4 equals 3x minus 1 over 4. Or you could do x plus 3 over 3x minus 1 equals 4 over 4. Pretty sure you can do that way as well. So then I'm going to solve for both. Let's do this one. 4 times 3x minus 1 equals 4 times x plus 3. We distribute 4x plus 12, 12x minus 4. Set them equal to each other. Subtract 4x, add the 4. Just kind of fast forwarding the math here. And we get 16 equals 8x. So therefore, x equals 2. I'm going to come back to that. I just want to show you that this other one works as well, and I'll do the math really fast. 4 times x plus 3, I'm going to distribute it in my head here, would be 4x plus 12. Then when I distribute here, that'd be 12x minus 4. That's actually the same as what we just had, because when we subtract 4x and add 4, we will get 8x equals 16. So you turn out to get the same answer. So either way works. You can go left to right proportions or top down proportions. And it wanted to know side AB, so we simply plug in the 2 for the x, and therefore AB equals 5. 2 plus 3, 5. I like that one. And then we have the converse of theorem 60-4, which says if parallel lines cut congruent segments on one transversal, then they cut congruent segments on all transversals. So what this one's asking to do is we're doing the converse. So in the past theorem we had, if lines are parallel and they cut transversals, then they're proportional. Now we're going to say, okay, if they're proportional, then the lines would be parallel. This one's saying, are the lines parallel when x equals 3? So we're plugging in 3 for here, and we get 4 times 3 minus 1. 12 minus 1 is 11. Plug in 4 here, and get 5 times 4, sorry, 3. I don't know where I got 4 from. 3 minus 3. 15 minus 3 is 12. Okay? Well, if I was doing a proportion, you would see that 11 over 12 is not equal to 14 over 14. So therefore, the lines are not parallel. That's kind of the converse of what we just did. But that's how you solve for proportionality theorems. And that is the end of lesson 60.